In the spring of 2021, in the midst of a global pandemic, I was lucky to be able to catch up with Rick Anderson, an old friend and contributor to the Arduino and chipKIT core libraries, and talk to him and have a conversation about embedded development from a open source and students' perspective. I hope you enjoy the conversation.
All right, cool.
This I've never really used Zoom to record. I don't know. You still teach at Rutgers too?
Yep.
Okay.
So yeah, I the part-time lecturer, but I'm director of virtual worlds and game research and immersive design. So
Wow,
yeah,
that's a title, a mouthful title.
yeah. So director of virtual worlds for short has been the thing for the longest time, and I've built this group up over the years, and we're doing all kinds of cool stuff. Um, so the biggest thing lately has been incorporating machine learning into projects. So I've been doing these autonomous vehicles with the Raspberry Pi and the Fubarino boards, and I think I converted to Teensy and next to ESP32. And that's really cool. But like machine learning on the edge is kind of where I'm going with a lot of stuff. So you can get tiny ML, so you get that on your microcontroller, which is pretty amazing. So I'm only just starting to explore that. But I have been looking at TensorFlow on Raspberry Pi, and that works just fine. Training, that's a whole other story, but just getting it to do stuff, it totally works. So
That's cool.
Yeah.
I made I haven't delved too much into machine learning, but I have I've done some facial recognition stuff with OpenCV.
Oh yeah.
And so I was working on an app that would take roll for my students that came into the class.
Yeah. Actually, one of the things that hasn't happened because of COVID is that I'm the tech advisor and one of the originators for the information technology and informatics capstone course. And that was make a thing and pitch a company around it in a semester. And so that idea about taking role from a device or something like that topic has come up a couple times in the capstone.
Okay.
It's such a cool and weird problem. It's an interesting problem when you're trying to balance invasion of privacy with with the goal that you want active learners in your room. You're not necessarily looking for bodies in your room.
Yeah.
So you really want people to be active and engaged. So this problem that's okay, sure, I got a picture of everybody and sure I know who they are, but it only tells you so much of the story. And in terms of the way the university and the school looks at it is well, if they're engaged, then that's great. If they're there, one part of the school says, great, the body's in the room. And then another part is but if they're there but not participating, right? So then your design of the actual project starts to modify. Mm-hmm. You can get cheaters, all kinds of stuff. So for instance, a lot of this was Bluetooth. I've got a phone and I can count all the Bluetooth devices, or I've got Wi-Fi, I can count all the Wi-Fi devices in the room. But then OpenCV comes along and says, oh, I can look for faces in the room. So that flips the thing from I can cheat by having somebody bring my device through the door, but now your face has to come through the door.
Right.
So interesting.
So I set it up, so this was really interesting to it, and it really made me think. And I shared it with the students to help them think about this too. I set up the camera, and the way it's set up is it just, as you walk through the door, it would go, oh, there's a face, take a picture, and log your picture to the hard drive. Mm-hmm. And so everybody came in, and it's just sitting there, and nobody noticed, right?
Right.
And then I started class, and I said, look, I'm working on this program, and I showed everybody's picture got captured.
Yep.
Right. Yep. And it's it kind of was an aha moment for me too, and realizing holy crap, if I could do this, anybody can.
Yeah. That's why like facial recognition is such an interesting problem because yeah, it like for instance, using it in a classroom, right? It has its own small world of use and ethics, etc. But then you apply it to anything that you have a photo of. I did a time lapse driving across the country, and I have license plate numbers for like every vehicle I saw.
That's
You
right.
know? And so every time you collect information, it comes with all the stuff that you've collected, right? So
Yeah.
then one of the things interesting in machine learning, so let's say OpenCV, it just tells you all the faces, and then you look at the faces and say, these are the people in my class, right? Machine learning can add these are all faces, and these are who we think they are for confidence value.
Mhm.
And so one way you can use something is to simply say, I just want to know that there are people in the photo, but I don't want to know who they are. And then, of course, for attendance, you do want to know who they are because they're attending. So
Yeah.
there are times where you could collect less information, and that would, what is it? Collecting less information may not be great for attendance, right? But it might be good for something else, like, well, how many people came to class, right?
Yeah. Well, and so another application, I had a friend that he was doing home automation for new home builders. And so he was contacting me to see if we could come up with some interesting things. And so one of the things we thought about was trying to know where people are in the house with cameras without exposing those cameras to the internet, because you may be walking around your house naked.
Oh yeah, right. You're getting information in different ways. That's why, like that microcontroller and the other, like there's like let's say there's sometimes more than one way to get your data. One of the funniest things that a conference I went to does relate to the story about where are people, is that they created these badges, and the badges were like it was actually one of the Hope conferences. And what it did was there were enough like Wi-Fi, or there were points across the whole hotel and your badge, and it triangulated where you were. And I'd have to say, after playing with the data for a while, I was pretty sure like where the bathrooms were, right? Because because you're either sitting still during like say being in a room for a conference, or you're sitting still in the bathroom.
Yeah.
So like there was some data that just became apparent much more early than others. And this is interesting tech, right? Because it wasn't tracking faces or people and wasn't real live cameras, but you're still figuring out like, okay, this person went to the bathroom at this time and they were in that room for this length. It just, like you start getting data that you're like, well, maybe that wasn't my intent.
Yeah.
But that was more reliable than like knowing like the edge cases or even the middle of the road data. That was just too apparent.
Yeah, very cool stuff. Super cool.
Yeah. So I like to play around with all these things and just give it a go and see what happens. But yeah.
So like I wanted to start recording earlier because I figured we'd talk about some kind of outside of the scope stuff, and we can make it all available. But I shot over those questions to you, and what's really interesting about talking about this stuff too, right? Where I teach, it's a 2-year school or junior college, and I think there's kind of like 3 types of students. There's people that are right out of high school, and there are people that are changing careers.
Yep.
They maybe have a degree already and decided that wasn't for me, and electronics looks more interesting. And then there's retired people that are coming back for entertainment.
You could. Yeah, it's interesting because there's I'm like kind of in this interesting position at Rutgers because it's a 4-year college. So it sort of thinks that all the students are 18 to 22 in age. But it's totally not true, right? We have non-traditional students. We have people who take 6 years. We have people who have retired. We have job changers. We get all of the above too. But there's still this prevalence because there's like 50,000 students, and there is a majority in this 18 to 22 category. And it's just, but the weird part for me is that would say my big chunk of my job is working with faculty and getting their courses online and using technology to do it. But then the other part of this is, oh, what the heck is it? It's like got multiple hats. Oh yeah, that's is that I'm also part of continuing studies. That's actually where my job is based, is in the continuing studies part of the university. So that's lifelong learning. That's you have certificates that you need to complete. You got trainings that you need for competencies. So it's a really interesting space. The university normally thinks 18 to 22, and then you go like, well, there's non-traditional. And then you're like, oh, continuing ed, well, that's a lifetime of people and coming back for different reasons. And, we even have the OSHA program, which is the basically courses for retired people. And they have like a whole community, and ex-Rutgers or past Rutgers or retired Rutgers teach for it. And then they take classes from that. So yeah, we got, so I kind of, what is it? So my vantage point has been across the board too. So like, community college is a good cross the board view. You don't get like one kind of student, and that's really important, I think.
Yeah, well, I mean, what the reason I was thinking about it was because I know Rutgers is a 4-year, and they probably have masters and maybe even doctorates programs there, right?
Yep, absolutely.
Yeah, and so like the depth of the projects you were talking about, they just don't show up at a 2-year school.
Yeah.
Right?
Like the capstones that I do are at the end of 4 years.
Yeah.
I would like to have them sooner. I'd love to have them within the first 2 years, actually.
Yeah.
But really, that just it's actually really one of the hard parts, is that in a traditional 4-year school, the cool stuff is in your senior year.
Yeah.
You get to do your own project. You get to do all this stuff. Sometimes it's flipped and you get to do stuff early. But yeah, after 4 years, being able to the first time you get to show off, it's both interesting because you've got all that experience, and it's also 4 years from when you started. So
Right.
and a community college person might get some experience, transfer in, and then in 2 years get to do their thing. So
yeah. Well, but it's also, I mean, the reason I bring it up is just it's nice to be able to, like, I'm always encouraging students to go on to we back up to Cal Poly Pomona, which is a 4-year school that's right next door. Literally, the two campuses are back to back.
Yeah.
And so I think a lot of students are like, they just want to get out and get a job, but there's some interesting things that go on at a 4-year school that you just don't get at a 2-year school. And so it's kind of neat hearing about that.
Yeah. So it's definitely a segue. Like, you can, sometimes it's a dive deeper in, sometimes it's a different set of choices, but there is kind of a continuation or a specialty, or, something comes out it's pretty cool. So, but yeah, that's the thing, is like, I've been working with seniors and their final projects. And I guess the other part is I'm co-founder of the Rutgers Makerspace. So that's also neat because it's a non-traditional learning environment in the middle of a very traditional university. So that also provides interesting options. People who are in the arts or history or the humanities get to play with microcontrollers. So that's a sort of a mixture that, may or may not happen in the, I would say it wouldn't happen if you didn't have the makerspace. But if you do have the makerspace, suddenly more people have some tech interests that really cross over. And then those projects are also super fascinating. So,
we have a makerspace at Mount Sac, and I'm not sure kind of what the status is. We kind of had some funding for a couple of years, and it was kind of, the intention was that we had to try to find alternative funding, and this was kind of like starter funding. And there's a couple of us that have at least been involved as an advisory role that are part of another makerspace that's nearby.
Yeah.
And I'm sure, like, I got sucked into it because I'm a member of that other makerspace. And but it's really neat, and I've been over there a few times, and just always a ton of students there. And I mean, it was something I wish existed when I was in school.
Yeah.
True.
I think back on it, and I guess the crazy part was I went from high school to like San Diego State at the time, and I was a music major, and I was interested in technology and music, and there was a little bit of it going on. It was really interesting, but I couldn't afford any of it,
Mm.
and there wasn't really a makerspace where you could get your hands on stuff. There was a bit of a electronics lab where you could get your hands on things, but San Diego State in the early 90s was interesting because it had like the best of the 1970s. It had like all this amazing recording equipment and electronics for electronic music that was like basically, fresh and new in the 70s, but in the 90s it was old and antiquated, except that then it was retro. So you made tape loops and you were actually making real tape loops with tape. You did these things that you kind of have metaphors for now that sort of help people think about how sampling, and you loop your samples and you have to cut things a certain way.
Yeah.
Those all came from physical activities people did, and having this weird moment of being in a lab that was like in between times that really like gave me this perspective.
Yeah.
But it was then also impossible to afford for me. I had this weird thing. I couldn't build my own synthesizer, but I'd look at all this electronic stuff and then I'd be, okay, I gotta have this and I have to pay this and buy that. And just wasn't affordable to me at the time. And then this will actually come back to Arduino, which is back in 2011, 2009, somewhere there. I sort of got introduced to Arduino and I was like, oh my gosh, this is a lot cheaper. And I can do
Yeah.
some of the things that I thought about doing. And it was, for me, kind of crazy. It was like, almost 20 years since I was like, oh, these are really cool ideas. And then 20 years later, I get something that's cheaper that I can now build my own stuff out of and get new inspiration from. And the things that I thought about the first time I went to college, are like, oh, I could try that. Or, so like Arduino opened this door up for me. And I was like now able to afford to do projects. And not so there was an affordability factor. And then there was oh yeah, I've been coding, I've been doing this stuff, I'm a regular programmer and I try lots of different things. And oh, look, this is C and this is C++. And oh, this actually does a thing on a device. And,
Yeah.
it sort of just opened up a new avenue that wasn't Java. I had just been doing Java and then Python and Perl and all kinds of other environments. And, that one at the time, it just kind of stood out.
So you found Arduino in 2000. Yeah, I mean so I knew. So I was kind of thinking about this, and I was like, my daughter was born in 2011, and I took a few months off right after she was born, and turns out newborns don't do a whole lot. And so I found I had a bunch of time to kind of contemplate life, and what I ended up contemplating was that Digilent had built this Uno 32 that was Arduino compatible.
Yeah.
And I had heard about Arduino, but I had some misconceptions because I had heard an interview with Massimo on some podcast, and I thought Arduinos were Java based. And it was just that the GUI was Java based.
Yeah. I ran into that all the time too. It was so one of the things that I did in this whole set of projects was jump into the places people weren't wanting to look. And so I think there's an amazing history here. One is that when I jumped in and I was like, how does this thing work? And, how are we going to make it multi-platform? Like I jumped into, all these interesting ideas. But
so you mentioned multi-platform though, but so how did you get from Arduino to chipKIT?
Oh, so that's a great story there. So, I guess I kind of look. Okay, well, since we talked about makerspaces, so I'll go back to that. So I had a student from the ITI program at Rutgers where I taught like how to hack a website together, but like how to do like web services and come up with a summer project. Like what's the latest in web tech, and we want to do something over the summer. So the student is this guy Phil Gilhouse, and he did this game of he set up a scoring system for Nerf, so you could go out and like play out in the middle of nowhere and shoot Nerf darts at each other and have like an amazing time. But he was working on a project for that. And then, so he was my student then, and then I lost track of him for a couple of years, and he showed up and it's like, hey, I had some friends, we're trying to build this makerspace. Do you want to meet us at the comic book store and do some stuff with that? So essentially I ended up going to the comic book store, meeting a bunch of people, and there was sort of they had been meeting since July, and I kind of popped in a little before October to Halloween. And so the first things that kind of happened was, oh, we're starting this makerspace. We're going to call it Fair Use Building and Research Labs. And so that became FUBAR Labs. And then a short time after that, and Mark Sproul, who is kind of a giant among the microcontroller crowd, joined FUBAR Labs as well. And he was a coworker of mine at Rutgers. So we kind of like brainstormed things. I was like, oh, I'm learning Arduino and this is really fun, and let's make some classes and let's get stuff going. And so I helped set some soldering classes up. I set some Arduino classes up, and we started our nonprofit, FUBAR Labs. And Mark was there like, you can basically take Arduino and port it to anything. And I'm like, well, that's very fascinating. Tell me more. So Mark actually was one of the people who showed the technique in Atmel chips, how to generalize your Atmel chip so that any Atmel chip that you could map your pins to would work under the Arduino IDE. Mm-hmm. And then like with a little finagling, they adopted that sort of approach because it meant the pin abstractions weren't hard-coded, they were dynamic, a little bit easier to throw a new chip in, even if it was under the tool chain. So Mark then was like, holy smokes, this stuff will, if we just do pin mappings from one chip to another, as long as we have a tool chain that can actually compile, we're actually able to do any chip. So Mark started contacting people, and he contacted the Digilent group, and the Digilent group kind of contacted him. So I don't remember precisely who did the thing first, but Digilent was working on it, he was working on it, and then they combined together. And then it was sort of like, okay, it's a PIC32, this is a great chip, it's 50 megahertz and it's got all this stuff, and we got to figure out how to fit this in and how these bootloaders work. And so for me, like, Mark had come up with a really innovative, really nice technique of like that mapping and the technique for doing the multi-platform like strategy. And then what I did was I listened really carefully. I read all of the developer lists, and I was like, Massimo doesn't want this kind of solution. Massimo wants this kind of a solution. So then what I ended up doing was, I went to the open hardware conferences. I met Massimo. I met all of these people. David Mellis was the IDE guy. So I met all of these different people, talked with them, listened to them, and sort of compiled together like what I thought they wanted. And then I started taking what Mark was talking about. And then essentially I was like, well, let's create a recipe that says this is going to be the way each of the different platforms maps. So I'm like, okay, well, here's your tool chain. And I don't know how many times I compiled tool chains from scratch. So that was like compiling compilers, woo, hours. If you want to spend hours doing something real boring, just compile compilers. And then eventually, like, I figured out the pattern. So I found the pattern, I documented the pattern, I got it in, and the PIC32, Digilent, and gosh, it's also all the names of the people, like Gene Apperson. Yeah, so Gene Apperson. So he had figured out more elements, and there was sort of a maker fair. I wonder if it was 2011 or maybe a little before, but basically it's the maker fair I met Brian at. So we're angling. We'd never met. We'd been working for over a year, I think, at this point. And so I came up with the recipe technique. I got the tool chain structured. I adjusted the Ant build system. And then I figured out the Arduino IDE had hard-coded so many weird things. And then it was, oh, hold it. And so I went on a whole adventure. And the adventure was, I couldn't do everything I wanted just in the Arduino IDE, so I had to fork it. But I didn't really want to fork it forever. And so what I did was I forked it so that we could get the job done. And then from there, I was able to play around with the pattern. And then I committed the code back into Arduino right after we finished it. So we really like forked it, figured it out, and then committed the code. And that's the thing that I think is really neat is I have my multi-platform code commits in the Arduino interface. So what it did was it allowed you to zip everything up, compile it, drop it in, extract it, and now a new compiler and a new chip and everything was ready to go. And we worked on this. And I think for that Maker Faire, it was like the night before I discovered some crazy deal, like Windows pathing didn't work properly in Java the way it was supposed to. And I had to go through and change all my double quotes to single quotes, or I had to go in with a regular expression and just rip stuff out left and right, hoping that it would work by the time Maker Faire started. So we had this last minute just crazy. Everybody, Gene Apperson was there, more people from Digilant were there, Mark was there, Brian was there. I just, Guy McCarthy, and then, I didn't, and oh man, one guy, oh shoot, there was one more. Oh, I can't, why am I forgetting him? He was one. What's that?
Keith, or was that before Keith?
No, it was before Keith, but Keith wasn't far away. But it was another microchip person. He got us the interviews and got a lot of the marketing stuff, but then there was a marketing person as well. So yeah, the name will come back to me, but it was
he was the university guy.
Yeah, he was the university education person at the time. Yep. That's right. Yeah. So yeah, we had this good group and we really worked hard. We got the stuff together. We got it all put together. We showed up, had our own booth, had like food bar flags, and we had all these different things going on. It was just amazing. Mark was there. So like, look at the Mandelbrot like pictures and stuff. Look how fast they're going. Look at all this stuff. Look, see how fast it goes. And like this whole Mac demo thing on there. It was just such a cool thing. And then that weekend we won the blue ribbon for I think pretty much the chipKIT platform, the PIC32 stuff. And really the thing I was most proud of was that was the first multi-platform setup that worked, because you could, in MPIDE, you could switch between Arduino and PIC32. Yep. And that's how I made sure everything worked, was I could flip between the two and it was all good. And I was like, we did it. This was awesome.
So when you go into preferences and you could add in your little string for downloading your different cores, that's your fault.
Yeah, it's my fault. You can blame all of it on me. So yeah, that was me channeling what everybody wanted. I got that in there, and so yeah. So the way it presents itself is there. Mark is the design that I then figured out how to jam into that interface. So it's so cool. But yeah, so I was so proud. And then it took 5 years before Arduino really brought the changes into the Arduino IDE itself. The code was sitting in the repository for that length of time. And then just to sort of fast forward the story, was the ESP8266 came out. They used the all of the files, everything that I'd set up, put their chip in it, got their compiler going, and boom, you could do 80266 or 8266 chips. Oh my gosh. So they used it even more than we did and got it out the door. And then at that point, it had snowballed. Everybody was making their own tool chains and throwing their own stuff in. But it was a wild ride, because we had a 32-bit Arduino 10 years, almost 10 years before anyone else did. So it was kind of a crazy scenario. We had such interesting chips.
Yeah.
And I would say in terms of speed and other things, those chips are still relatively, they're still valid. Like the Fubarino Mini and the Fubarino SD, they still are at speeds that microcontrollers are, all those Atmels didn't really go at, and they had so much more IO and a lot of
still using Arduinos. They're still using Atmels.
Yeah.
Well, microchips now. I don't know what you call them.
Yeah, so that was one of the interesting things. Is the weird part about microchip was that people thought that us doing an open source implementation and doing all these things, that they were looking at the brand microchip And the crazy part was Microchip really had the education person. They had Guy McCarthy, they had some good people, but they did not really put money into this thing. We all did this because we wanted to get, microcontrollers running Arduino everywhere. And it really didn't matter. I mean, Mark went and worked on other platforms, and other people like the ESP chips, they got their stuff in. And so our vision did come true. It really did.
Yep. Didn't Mark also work on Garble?
He did a little bit of stuff on that too, I'm pretty sure. He worked on so many things, because like essentially whenever there was a chip, especially an Atmel chip that didn't quite fit the thing, he would just go and figure it out and like put it on his list. And there he had this list of AVR chips that could all run Arduino, and he just anytime it had to do that, he would just figure it out.
No,
so.
I may have talked to Mark once, there was this announcement for the Uno 32, and I bought one, and I'm trying to figure it out, and there was no documentation. And one day I'm like, I just picked up the phone and called Digital, and I'm like, hey, I got some questions. I'm trying to set up some pins or something on this thing. And they patched me through to Gene, and he's like, you need to get on this message group. And
yeah. Well, because you always ask these really great questions, and then is always having the follow through for all the questions that you got. All of that was awesome. And, the more we could get people into the mailing list or get people into the sort of talking about it, the better.
Yeah.
So it really, really made a difference when people didn't just ask the questions, they followed through with all the stuff and then added to the conversation.
Sure. Yeah. So, I mean, I've been using PIC since the early 90s, which is to say, not long after Microchips was a company.
Yeah.
And the first PICs we used, the PICs we were using were one-time programmables. And so when we were debugging our code, we were burning through one-time programmables. Yeah.
Ouch. Wow.
$6 or $7 every time you have a bug, right? And so
you're like, I got it now. Whoa.
Yeah. And then
that definitely is that cost factor. I mean, really, there's a variety of things that brought those costs down. And I went to many a makerspace, and they were like, "Oh, you should make your own Arduino. Use these chips; it'll bring your costs down. Why is Arduino 35 when I could make one for 5?"
Yeah.
It's like, well, no, they're trying to set a standard. So, like, if you go and buy an Arduino someplace, there's at least a company can resell it at a certain value. I mean, there's a lot of logic to how they pick their prices, and then they just kind of held. But you see now, these prices are all over the place in terms of chips and options and quality. So that part of the world changed quite a bit, from just the genuine Uno to, like, I don't know how many chips under the sun and the blue pills for $2 and all this stuff.
Yeah, Brian was saying though, the problem with the blue pills is they're counterfeit chips.
At least some of them might be.
Yeah, I don't know.
Yeah, no, the thing that interesting there is this is kind of gets to the weird murkiness of, so like who's in charge of what, right? So there was a big community effort to get those particular STM32 chips into Arduino, and that went for a long time. And then I think one of the personalities that really pushed it sort of moved out of the way, or STM decided to really take an active role. And it turned out that the timers and the interrupts were implemented a certain way. And it turned out that when the PIC32 came out, the competing 32-bit board was the Maple board. And they wrote these interrupts back then when the PIC32 first came out. And they had forked the IDE as well, and got all their stuff nice. But you'd scroll forward 7 years, and the STM32s that were kind of those chips, but just down the line more, what did they do? They had was that they were still using the same interrupt routines that were developed way back 7 years ago. And so I think STM was somewhere in that decision matrix where, like, you lose track of it, was like, oh yeah, we want to do them better. And so they ended up without them. So I keep having to go back to an old version because it had these like interrupts that worked a certain way. And then I went to a new version and then they just simply didn't have it. And then they started having some of it because they're working towards having what they want.
Yeah.
So it's an interesting like thing where it was like I sorted this problem and I discovered that its origin was back at the same time we were doing the PIC32, getting it rolling with Arduino.
And chipKIT has some of those problems today.
Yes, I know.
There's
Yeah.
I was just posting earlier that like what frustrates me is stuff that used to work doesn't work anymore.
Yeah.
When we went
So
away from plib.
Yeah. So there was this big effort to make sure everything was open source. And then you have to figure out at some point you still need information. You still need pin names and you still need a lot of stuff. And if you at some level, if you're completely separated from it, you may actually lose the functionality. So that was something that kept going back and forth was, do we use the plib stuff or we don't, or what do we use? What's the interface? Yeah. And you go back and forth through that enough times, errors occur,
And plib is it's the non-open source library provided by Microchip that they let the chipKIT organization use for only for chipKIT.
Yeah. And I think we got rid of it eventually, if I remember correctly.
Yeah,
so you would sort of rely, I guess that's right. That's why you would have that problem is that it worked. Of course it worked using the plib. And then as we moved away from it, those things then stopped working or had to be fixed or
there was these there were some guys in Russia or something that they built a library that worked on top of plib that allowed you to leverage the Android ADK to communicate from a PIC32 to an Android device over the USB port.
Yep.
And we built some cool apps around that. And then when we went away from plib, it broke.
Yeah.
And I didn't write it, so I don't know how to fix it. I could probably figure it out, but it might take me, 4 weeks.
Yeah. So that's the thing about community projects, right? Is like, so you have the community, you have the company, you go back and forth. So we're always trademarking, because one of the only ways to protect your materials is trademark, because you can swap out chips, but if your trademark is Arduino or your trademark is chipKIT, then if you called it a chipKIT and somebody else called it a chipKIT, you can protect it. So in this scenario, it's like the companies are involved because it's handy for somebody who has access to lawyers to say help enforce your trademark.
Mm-hmm.
But same time, you're trying to get away from all of that, so everything is open source and everything is working properly. But you go back and forth. So I would say like now we have the issue with Microchip is finally like, nah, yeah, we're gonna go with that Arduino stuff. And so chipKIT is sort of on, kind of being launched on its own at this point. And that means the trademark and other things go away from Microchip. So it's a new territory, a new space for it. But for instance, if we had to renegotiate access to plib, for instance, that would then make this moment a lot more of a headache. But the headache we have right now really is just making sure there's a 64-bit version of the compiler
for Macs.
Yeah. So those are the things I think are super unfortunate, is that you can know a project strategically needs a thing.
Yeah.
A company, you ask for resources because, well, it's your compiler. Can you just give a 64-bit version of it? And then that becomes a whole conversation that takes years.
Yeah.
And then you have people like Matt Jenkins, who's like, oh yeah, I just compiled the 64-bit one up just the other day, and I was like, wow, holy smokes. So suddenly you have capabilities you never thought, because you have such amazing people contributing code or contributing time.
Yeah.
And they're like, yeah, we know we need this, but it still takes time. Even like 90% gets you pretty far, but 90% is like that classic part of the project where you realize how much more work you have to do.
Yeah, and I think, what I thought was neat, it's a really good point, right? Is because when I found Uno 32, like I said, I've been using PICs for 20 years at that point.
Mhm.
And we've been using PIC32s for about a year. And so I was familiar with the chips, and we had solved a lot. I mean, what it was for me, I think, what kind of, it was kind of, you can't beat them. If you can't beat them, join them.
Mhm.
We had spent years developing all these libraries, and our libraries were so good. Our SD card libraries and our USB they worked so well, so rock solid. And then here comes Arduino, $20, poof, everything's there. And it's like, and so we said, well, let's embrace it. And we knew there was some problems with it, but we're like, it's mostly there, and we know how to solve the problems. Let's just fix the problems. And so that's when I called Gene, or when I called Digilent, and they put me in touch with Gene. I was like, hey, I can't figure this out. And Gene's like, oh, do this and this. And I was like, okay, let's just start fixing these problems. And so the community could help solve that last 10% where someone has a.
That's true. You can carry the burden pretty far, but if you get the community to help you to get to the end of the line, that actually is critical. No, that's really important. It's a really good observation. Like Arduino started popping up libraries, but they were pretty haphazard.
Yeah.
So there was a lot of work to do. A lot of things
them still don't work really well.
Yeah.
Like I think the I2C library is just not great.
Mm-hmm. Well, there were design decisions to not implement all of the features.
Sure.
And then later on, people brought them back, and then now you have multiple choices for your I2C libraries.
Mm-hmm.
These are things where I actually think what I'd love to see is governance across all Arduino. Kind of the way like Linux has governance. It'd be great to have both big companies, small companies, and the small fry and the people just interested saying, okay, we could put a boundary around this problem. It's got these things, we want these features, we like these features, and as a whole, there's enough people to actually put that together.
Yeah.
It just never really coalesced into that. Like the chip makers, I think in some sense, the more I learned about chip makers is that their margins are pretty low. They're not interested in the education portion as you would figure. Like they are, but they aren't. It's an interesting problem.
Mm-hmm.
But they so the software was something that they weren't all willing to give away, but most of the software they end up having to give away, because you need people to use the software to make your chips do the thing you want them to do. So there's been a lot of just different things. So Atmel and Arduino had a good relationship. Microchip, Atmel, Arduino. I think the people who were part of the Atmel, they did a great job and still are in the mixture. But it's like but it's still not really governance. Just haven't quite got that worked out. And that's like chipKIT itself. That's what we're trying to figure out right now, I think.
Yeah. well, and I think one of my motivations of this was to try to encourage some of my students to get involved, because they will. And I think this will be week 12 of the class where we kind of present this, and I kind of have, and you mentioned interrupts earlier. That's the week I'm going to introduce interrupts. So that's good. But hopefully that I could convince some students that get involved with the community. And I mean, there's definitely some students, I could already tell a couple weeks into the class, there's some students that are just like picking it up like water.
And there's such fun things to do. And there's plenty of big and small projects. That's the thing. It's like sometimes just finding the one thing to worry at and fix is just good enough, because then you learn the pattern and you learn how to do that. Like actually one of the things I helped also introduce was I helped bring, basically got chipKIT started in GitHub and got all the code over there and organized and got version control working and got our issue tickets up and running. And of course I did this with all these various people, but I helped set up what was the open source development structure that we adopted. And, it was because I had experience with open source software as being a an important part of my, software developer, or, well, I was still doing pretty crazy stuff. I'd started the IT department for all of continuing ed. And then we branched out into like, what was it? Branched out into everything from like web hosting to, everyone's database and data management. And then eventually I just started focusing on web stuff, right? So all of the web environments that I started working with were all open source based, and you could go and contribute and make changes. And so then Arduino was supposed to be that way too. So then I just brought over what I knew from that community into the other one. Mm-hmm. And it's still there. It's still working. You can keep track of all the bugs since the beginning.
Yep. All the bugs are still there too.
Yeah, exactly. Just waiting. Yeah. I would just say my lesson there is that, like, sometimes when it's hot, you have to push people in a good direction to go after certain things, because like as you go there, you start living with the troubles, so this is like where like the change notice stuff drives me crazy, or like on change part of the interrupts. There's a bunch of libraries that Paul Stoffrigan and Teensy and other people all put together that we couldn't use because we didn't have the change interrupts. And I was like, well, my next set of projects all involve rotary encoders. And so I got great advice on how to code those, but I wasn't able to do it the Arduino way, right?
Okay. I have on a PIC 18 turned a on change interrupt into a rising or falling interrupt, and I've turned a rising falling interrupt to an on change interrupt. Mm-hmm. So it's not hard to do. It's just like 2 lines of code. It's just someone's got to do it.
Yep. So what happened in that case is it just happened to be one of the problems that got, like you get 4 or 5 problems that kind of just stay on the pile.
Yep.
And it was just, there was one more thing important to tackle, and so it stayed on the pile. And that's a contribution that also makes a big difference, is like if people notice what's staying on the pile, and if you can knock one of those off, then you get a heck of a lot of good credit for solving a biggie.
I think, and I like, one of the problems I've had is I get so frustrated trying to build the whole tool set in Windows. But these days I'm using Linux a lot more. So I think I'm going to try it again in Linux. And I think I feel like I'll be more successful.
Yeah, there's a couple of layers in Windows, as well as like pathing troubles that pop up sometimes. And usually if you don't have to deal with it, it's much better to not deal with it. And the other part is like we've what is all the stuff, there's a bunch of neat new things to look at. There's like GitHub Actions. There's a lot of virtual machines and Docker stuff. So we might be able to do cloud builds and cloud testing in a more efficient way than we used to. The project came up just before DevOps was a thing. And so like DevOps is a big deal. You can abstract a bunch of stuff into the DevOps environment to make our builds easier, our testing easier. That's another thing I like to see is you change code and you don't want it to like re-break something. So we did pretty good, but every so often you find something you re-broke, but having testing will help quickly, did you break that or not? And we do have it, but it's prior to the modern DevOps way of doing things. And so there's some future direction that regular, like say your regular DevOps person would be like, oh yeah, obviously you do this, like, oh well, that will help us a lot.
So I mean, I guess so the other thing I saw with chipKIT that was kind of worrisome was, like, it seems like everybody, it's both good and bad, right? Everybody now, it's so easy to get into it. $20 and you're into it. And like my original thought on this was, oh, I can't charge as much as I used to charge. But that was my original fear, right? But what I learned over time is there was a lot of people that can just do things a little bit, but maybe haven't dug in as deep as I have. And so there's still room for a valuable career in embedded systems, even with this broad.
Yeah, well, I think there's definitely what is it? The innovation is from the developer now. It's from the person going, I have this idea, I want to use a chip, I want to use a board, I want to make this thing. So the innovation is coming out of that space. You might get some new feature out of a big chip company, but that feature, how did it get there? Well, some customer probably said, we need these features.
Mm-hmm.
So, in chipKIT, Microchip monetized a lot of the how many analog pins do you want to have, or what kinds of pins? Well, we'll set up chips based on those kinds and very blah, blah, blah. And now you look at these ARM chips and they're like, we got all of it. They all do it. Why are you choosing? So the innovation from the customer was like, well, I don't want to I want everything. Why would I want some things when I could have it all?
Right.
But the story goes is that the thing you do with those chips, the things that you push and pull and you ask from those companies, that's what they get you. That's what they'll innovate. Their next version of the chip will, have some of the stuff that you want. And people pretty made it clear, they don't want, they want to use whatever pin for whatever reason, and have bunches of it, but then the next part is, learning circuit board design and making your own boards and thinking about the human computing interaction and how do people want to use it and work on the feel and the human side and solve these interesting problems, even if they're small problems. That, I think, is your innovation. Your career will come from that. And that's, I think, what's really neat is when you get you need some knowledge and you have to have some wants. And when you get a chance to mix them together, and then I think it even goes back to your open source community. Like if your community that surround you propel you when you ask questions and you go in those directions. So that participation in open source is a little bit of building that community, getting that motivation. And so I think in this space, chipKIT has provided almost more than 10 years of motivation for me.
Do you still use chipKIT often, or are you on other things?
I have a couple of projects that use it. So my autonomous vehicle project for a while has used the chipKIT, like the Fubarino Minis and the SDs. I'm starting to move away from those, but it took a long time. They still do everything that I need them to do.
Yeah.
But because I'm looking at this, how do I combine some machine learning in? How do I smooth out the signals? I'm considering, hey, what chip will get me that?
Yeah.
So if I can throw some sort of machine learning model, reduce the noise down, and get more reliable information off my chip, then I'm going to be pretty happy. So that's the one change I would say that's happened. If I wasn't trying to jam so much information on the chip, the machine learning model, that is, then the Fubarinos and the Minis and all those are perfect because they did everything I asked them to.
Check out this board. Someone just sent me this board from Gumsticks. This has a STM, or I don't know, it's an M7 ARM processor. I don't know who makes it. It might be.
Oh yeah, those are interesting.
Yeah. So it's a big chip. It's a huge chip, but it also, these two ports here and these four screws, that's for a Raspberry Pi 4 compute module.
Yeah.
Raspberry Pi compute module 4 plugs into it. These are RC servo outputs.
Oh, I'm already seeing it. Yeah.
And then these are Mavlink ports.
Yep.
And it's got, I think this is a Google TensorFlow chip. And it's got an IMU on it.
Coral right on it. Yeah.
Yeah.
Oh my. So yeah, so that's a bit of the future right there.
Yeah. I sit in on these Pixox dev group meetings, and the guy who's developing this is like, "Yeah, I got some boards that got problems. They work fine. They just have a couple of issues, and we're not going to sell them. Anybody want any?" And I'm like, "Yeah, I'll take one."
Sure.
And he sent me two.
That's awesome.
Yeah.
That's the other part is like when you're involved in the community and somebody's like, "Well, I got this thing. Were you willing to try it?" And be the person to try it.
Yeah.
That's really cool. Oh my goodness. Yeah, no, there's just another thing to note is all of those little connectors on there, they're a lot easier to order and get on your own boards. And there's like you're going to order like GLC PCB or something, you can get surface mount stuff. I think you're all familiar with all that anyway, but
Yeah.
but it's interesting that you can get assembled boards with these grid connectors.
Mhm.
That was one of the big things, was the older stuff was all 0.1 pitch, headers, and you're like, well, how can I use all the pins on my chip? Well, you
Yeah.
use these little ribbon cables, or you get those little adapters. So I think there's another like level up that the whole field and the Arduino world is coming through with that. Say the compute module has those things you pop on, and now your board has so many connectors that you didn't have before.
Yeah. Yeah, but I mean, so I guess what I was getting at is like, Raspberry Pis are cool. They're really super cool.
Yep.
But like, there's just some things that just work so much better when you don't have an OS.
Yeah, no, your real-time stuff. It's just so critical. And that's why I was thinking, is like, if I can smooth out real-time information with machine learning, then your Pi gets this nice solid piece of data.
Yeah.
And at some point you can start then saying, well, everything's so reliable with this particular setup. Well, what else can I do with it? Right? Your problems are going to change a bit. I think one of the chips that I've been looking at are these hybridized ones. It'd be like half Pi, half half microcontroller. and that, like, what you did right there is you pop them together. But the chip vendors are making chips that have both of those elements on it.
Yeah.
So we just haven't kind of, the chips are there, we haven't seen them in use yet.
Okay, I hadn't heard of that.
Yeah, they're basic. Yeah, because it's like if you look for the embedded Linux stuff, you'll see, I can't remember if it was like an A7 plus an M0 or an M2 or
right.
And as soon as you start hearing these two things are combined in chip space, you're able to like, oh well, there you go. That's the Linux side, and then on that same chip is this microcontroller that I want to have access to. So those are, I think we're at the second generation of those chips. But you also have to, like, instead of just being a microcontroller person, you have to be an embedded Linux person. You have to work all the way through that world. And Raspberry Pi clearly has done that, and a bunch of other people who do Pi clones or variations have been going through that thinking process too. So it's I would not be surprised to see suddenly that chip that you just showed us had the Pi in it.
Yeah. Wow.
Yeah.
I'm sure.
So anyway, that it's just but that's the thing. There's always something interesting, something to keep an eye out for. But I love that, and thanks for sharing that. That was a cool board. Yeah.
Well, I mean, we could probably talk forever.
Yeah, I'm happy to, but yeah, I guess we're almost at an hour.
Yeah, and hopefully the students will stay engaged.
Well, I definitely, I'm happy to chat. This is the sort of thing, like, what is it? We've done something for almost, I think I keep saying almost 10 years, but I'm pretty sure we're right at the 10-year mark.
Yeah,
and we've been doing this thing, and the stories haven't really all, like, there's a lot of stories to tell. There's a lot of fun things, and we all did microchip masters. We did all these different things that were super nerdy, because, like, what did we do? Well, we went and worked on chipKIT.
Yeah, and that's where that's where I met you the first time, was at Masters with Brian.
Yep.
And I'm sure we talked via email first. Mm-hmm. I know we did, right? We were all on email chats, and that was it was a different time, just 10 years ago, right?
Yeah.
I didn't know what you or Brian or anybody looked like before Masters. We just met there.
Yeah, we had worked together for more than a year, almost 2 or something, some cases.
Yeah.
Had not really met. Yeah. And so there's a lot of interesting things to talk about, and I'm happy to do it. So maybe we'll close this chapter today, but I would love to catch up more. And if we, Brian has great stories too, but we could try to grab some of the other chipKIT people.
Sure. Yeah.
That would be
all
awesome.
Right. That's great.
Cool.
And yeah, we'll hopefully we'll talk again.
Yeah, and we still have that list. We've only probably got like 1 out of 15 questions answered. So
Oh, the list that I sent you?
yeah, we hit
You
some of
covered
it.
everything though.
Oh, okay.
Yeah, like it was just a nice conversation that kind of, I think the list kind of just allowed it to, just flow out of your brain a little better.
Yeah, I just definitely appreciated it. Thank you. And thanks
Yeah.
again. This was really cool. I love chatting with people. And I know if it is, my day job is such a crazy thing at the moment, but I will try to join in on all of the chipKIT calls or something. Somebody put a Jitsi out. I'm a little bit confused on what's going on, but
yeah, I'm the one who mentioned Jitsi.
Okay.
And that's that was the PIXOC group uses Jitsi.
Okay.
And it's I don't know who, like I learned about it from PIXOC.
Oh, I use it for FUBAR Labs meetings.
Oh, okay.
Yeah, and I've been starting to use Discord a lot more.
I use Discord a lot
because Discord has got better streaming options and live stream options.
Right. Yeah.
Got lots of features.
I do a lot of not so much recently. Once the class starts, it kind of consumes my free time. Mm-hmm. I started teaching. I said I'm gonna teach because I want summers off, and so I looked into it. I went back to I went where I teach. I went to Mount Sac. I was a student there, and I decided I'm gonna go learn. I'm gonna go teach because I want summers off. And when I went in and I like, hey, I'm interested. I see there's an open position in the electronics department. I'm interested, and I want to find out, what it takes to teach here. And I dropped off my resume. And 2 days later, I got a call from the chair of the department, and he said, "You're teaching on Tuesday and Thursday in the fall." And I'm like, what? Wait, what do I have to do to teach here?
And they're like, oh, there you go.
and I'm like, well, no, because I knew there was qualifications. So he's like, well, you have to have an associate's degree and 6 years experience. And I'm like, I don't have my associate's degree. And he's like, get one before fall. The chair of the department was one of my instructors, so he knew me.
There you
go. When he saw my thing, he just called up and said, you're teaching.
Yeah.
He knew I was good. He was good, and and
that is amazing.
Yeah, it was easy to get I've been going to 4-year degree, so I just transferred back some units, and I was able to get my associate's degree.
Oh, okay, good.
Yeah,
that is also a beautiful thing about community colleges is that because if you've done that work, they will transfer the other way.
Yeah.
Yeah, they'll give you credit for what you do. That is always good. Cool. Yeah. Wow. Yeah. Nice. So, that's a very good start. Oh, wow.
Yeah. Yeah. I started teaching in 2000.
Oh, wow.
So I've been teaching 21 years.
Yep.
I was only 6 years out of Mount Sac. I barely had the 6-year requirement when I started teaching, but
I started teaching 2003 probably. I've been at Rutgers at 99 because I graduated Rutgers and then got a job and built out their IT department for continuing ed.
Okay.
I started teaching a few years in, and I was like part-time lecturer for the School of Communication and Informatics. And then, a lot of different things started over the years.
Yeah.
Huh.
Do you guys use Canvas?
We do actually. Yeah.
Okay. So that's what we use. And then there's another question I had for you. I can't remember. That was related to pedagogy. I can't remember now. But
I'm here for it. These are questions I handle.
Remember, I'll send you an email.
Yeah. Well, there's so many neat ways. I'm very interested in like how would you, how might we teach, microcontrollers online in a more interesting way?
Mm-hmm.
And a lot of it's come up through the DIY environment.
Yeah.
Teaching each other. But,
I mean, Khan Academy, I'm sure.
Yep.
And so, from the birth of Khan Academy and YouTube, like I really started questioning, like, what is the value of college?
Mm-hmm.
Right. And I kind of the answers I came up with was you get face-to-face interaction with a professional.
Mm-hmm.
You get face-to-face interaction with fellow students, and you can bounce ideas off of each other. And you get a curated
Right. Yeah. You have curated, so you have all of these choices and things. So yeah, you get an exploration that isn't chosen because of what your internal knowledge says. It's chosen from external forces and external reasons, and that takes you on an adventure that's sometimes unexpected. You're not necessarily prepared for everything that happens in college, and that is one of the good challenges, is that now you sort of you rise to occasions you didn't know you needed to do.
Yeah.
So I think there is an unexpected path that shows up. I definitely think you can find those people who are really knowledgeable, and that's one of the goals, is to find them and like figure out how that works, what makes them tick, and can you work with them someday, or what can you learn from them. And then there's also let's see, what is it, so you get the so funny, but basically the network of friends, the network of people that you build.
Oh
You
yeah.
meet people you wouldn't necessarily have met, if you stayed working at home, right? We don't meet as many people.
Yeah.
But going out to the school, meeting the friends, or even networking, and like the way we use Discord or the way we use these different technologies, we kind of expand that network of friends out. And I think that conversation and the community that you build, that is just absolutely amazing. And going to the community college, that builds one of those communities. Going to a 4-year college, that builds another one of those communities.
Right.
And that is pretty valuable. It's every conversation I've had has led me into some new project,
Yeah. My day job I have now, so I teach part-time.
Mm-hmm.
And I have a full-time job. I'm building these, I don't know if you caught it, I'm building these swarm robots. And the guy I'm working with there, the guy that brought me in, he and I have worked together at 7 different places.
Oh, wow.
And I know him from school.
Mm-hmm.
We met in our early 20s.
Yeah.
Yeah. And so you just meet people that are like-minded, and I've worked for him, he's worked for me, and we've worked as co-workers, right?
Yep.
It's amazing.
Yeah. And you wouldn't have known that. You wouldn't have been able to plan that out, right? High school didn't tell you that was going to happen later.
Sure.
Yeah. Super cool.
Yeah.
Super cool. All right.
Yeah. And I've got a ton of things I have to do still before the end of the day. So thanks.
All right. Well, I'll let you go. I think it was a lot of fun.
Yeah, it was fun.
And we will definitely do more. I'm sure of it. All right.
Thanks.
And I will sign off. Okay. Bye-bye.